Hello, we are back with few questions. So this in this question, we are looking for to calculate silver nitrate grams to make 250 milliliters of 0.05 molar solution. So I think I remind you, silver nitrate grams you're looking for, connect that to moles. The moles connect into molarity. Now, in order to do that, we need to know the molar mass. So you're going to calculate the molar mass for silver nitrate, which is silver is 108, nitrogen 14, oxygen 3 is 48 put together. Get the exact values from your book, your data book. So you will get something precise value 169.87 grams per mole. Right now, if we have this information, we can make this solution actually in the laboratory in a wet lab. So let's see how we do it, right? So remember, we also used molarity is number of moles of solute divided by liters. Now we have those. So we have the big M, we have the liters, right? So use the cross multiplication, get the big M, big L one side, simple in the other side, plug in with the units. Now 250 mil is 0.250 liters. Plug in, cancel the liters. Now you end up only with the moles, right? Simple N is moles. Now we have a moles value as I put it in the red on the top of the question. So now we have the moles. So simply going into the grams, right? Now, so we know molar mass can be expressed 1 mole per gram or grams per 1 mole. So either way, we need to cancel the moles. So that's why we write it this way, the exact way. Mole to mole cancels out. We left with grams. So 0.125 times 169.87, plug into the calculator, simple multiplication, and you get 2.12 grams in this case. So because we did so that amount is dissolved in the 250 milliliters of distilled water, right? So now we're going to write few sentences to how to do it in the laboratory on the bench, right? So how do we do it? So we need to have precise measurements. So that means we're going to take the 250 milliliter volumetric flask. That one precise, see, 250.00 milliliters. It's precise and there are a couple of grades, but that's what it is. Now you grab a funnel and you measure the 2.12 grams of silver nitrate in the analytical balance. Actually, it has to be up to the 4 decimals, and we'll stick with the numbers we have, right? Now we put that solid at distilled water 2/3 to half, 1/2. And this you add the distilled water and you swirl it and let it climatize, right? And then you look at with the eye level on the water level and you see the meniscus. You add with the squeeze bottle 1 drop at a time until you meet this meniscus, the mark of the 250 milliliter. So you see the bottom of the meniscus should touch the 250 milliliter mark. Now you have it, right? What I mentioned about the climatize means like some solutions could be hot or cold. You're going to let it sit there on the bench for 10-15 minutes to make it to the room temperature. That's called the climatize. That's it. Okay, we move on to the next thing. This part do not need other people like my normal students, but this is needed for the MCAT folks and the HB IBHL people, right? What this one? Dilution series. You need this one for data-based questions, and also actually if you're doing the micro lab or a series dilution labs, you need this one. So I'm just going to take only 4. You can go up to 10, 20, whatever you need, right? So you need 4 test tubes to do that. You have X molarity original stock solution, and then you're going to take 100 milliliter, half of to the next one. So that means 50 milliliter. So from 100, you pour 50 milliliter. It's not really pouring. You're going to use a pipette, right? It's a precise units actually, right? Then the next one gets from the second flat test tube another half, and you keep going. And every time the new test tube comes with the 50 milliliter of water. So what you are diluting every time half and half and half, right? Now this half and half and half is called the dilution factor. You see, every time you are halving the strength of the material, that's why it's called the dilution factor. Now, what's the use of dilution factor? You can do 100 dilutions. You just have to know this dilution factor. You see, half times half is quarter, half times half is 1/8, and next one would be 1/16, the next one would be 1/38. And you can go on, right? So the whole point, you can calculate the molarity of any test tube. All you need is the original stock solution X molarity times the um, dilution factor for that step, just the previous step. You see this final fourth one, I need the. Okay, we look at the next one. It's the same dilution series. You will be using 96 wells, and so you're going to do in the both directions dilutions, but I can simplify this one. Let's say you look at the shorter side, A, B, C, D up to the G, and each hole has a certain volume, or you can choose the other side, which is 1, 2, 3, 4 up to 12, right? So you can go both directions two dimensionally, but the idea is same as the previous four tubes that I diluted. Okay, now here, so what you do is you might be getting 100 microliter, or you could have 1000 microliter. So again, you transfer every time the same amount. Let's say in this case, I start with 100 microliter of a DNA solution, or maybe some serum. So you pass 10 milliliter, 10 microliter, 10 microliter, 10 microliter. And in this transfer, what you actually have is your dilution factor is 10 over 100, which is 0.1. So then if you go to the 1, 2, 3, fourth transition, fourth step between D and E, you have four dilution factors. Multiply that and it'll give you 10 to the minus 4. That 10 to the minus 4 times the stock solution, the original solution of the DNA sample, is the one actually for that volume, your molarity, right? So so that means you should be looking at, you're going from A to the B, B to the C, C to the D. Each has different molarities. How do you calculate? You know about the stock solution exact molarity, and then use the dilution factor. That's it. So send me the problems, I will discuss. Thank you.